Good day, everyone. Welcome to another opportunity of learning mathematics. I am Teacher Anna of Judge Juan Luna High School from the Division of Quezon City. This time we will discuss the laws of exponents, applying the example conclusion map. This lesson is included in the learning competency of Mathematics 7 and Mathematics 9.
To give you a brief background of what is example conclusion map or ECM, it is a problem-solving maps technique that develops inductive thinking abilities of the students, which will allow them to see the generic pattern from the given examples and eventually discover the rules. To illustrate the example conclusion map, from the upper portion you have the title or the concepts to be discussed. Then, you will provide 3 examples. From these examples, the students can produce a conclusion, and then later on, they can give their own example. As a review, exponent is a shorthand for writing an expression which involves repeated multiplication of itself. In symbol, it is written as a raised to n, where n is the exponent, which tells us how many times to use the base in a multiplication, while a is the base. It is the value that needs to be multiplied by itself. Let's say, for example, 2 raised to 3. That means 2 times 2 times 2, which will give us the value of 8.
Now, let's proceed to our main discussion. Basically, we have 7 laws of exponents, namely the product rule, the quotient rule, the power of a power rule, the power of a product rule, the power of a quotient rule, the negative exponents, and then lastly, the zero exponents.
Now let's start the discussion. To use the example conclusion map, let us begin with the product rule. Our examples are 2 raised to 2 times 2 raised to 3 is equal to 2 raised to 5. The value of 2 raised to 5 is equal to 32. Next example, we have m raised to 4 times m raised to 3 is equal to m raised to 7. Last example, we have 5 times 5 raised to 2 is equal to 5 raised to 3. The value of 5 raised to 3 is equal to 125. As you notice from the examples given, there is a pattern in simplifying exponents under this rule. From here, we can have our conclusion as, to multiply expressions with the same base, all you have to do is to copy the base, then add the exponents, and then lastly, simplify it if possible. In symbol, it is written as a raised to m times a raised to n, which is equal to a raised to m plus n. A stands for the base, then m and n stands for the exponents of the expressions. From this idea, you can have your own examples, which may be 3 raised to 2 times 3 raised to 2 is equal to 3 raised to 4, which is equal to 81. Lastly, we have y raised to 5 times y raised to 7, which is equal to y raised to 12. Next, let us have the quotient rule. Our examples are 2 raised to 5 divided by 2 raised to 2, it is equal to 2 raised to 3. Getting the value of 2 raised to 3, it is equal to 8. Next example, we have x raised to 7 divided by x raised to 3, it is equal to x raised to 4. And then last example, we have 3 raised to 5 divided by 3, it is equal to 3 raised to 4, which is equal to 81. Following the same procedure, from the examples given, we can have our conclusion as, to divide expressions with the same base, all you have to do is to copy the base, this time subtract the exponents, and then lastly, simplify if possible. In symbol, it is written as a raised to m divided by a raised to n. It is equal to a raised to m minus n. Again, a represents as our base, and m and n will be the exponents of the expressions. From this idea, we can produce our own example as 7 raised to 4 divided by 7 raised to 2. It is equal to 7 raised to 2, which is equal to 49. Next, let us have the power of a power rule. Our examples are 2 raised to 3 raised to 2, it is equal to 2 raised to 6, and the value of 2 raised to 6 is equal to 64. Second example, we have y raised to 4 raised to 3, it is equal to y raised to 12. Then last examples, we have 3 raised to 2 raised to 2 is equal to 3 raised to 4. It is equal to 81. Based on the examples given, we can come up with our conclusion as to raise expressions with exponents to another exponents. All you have to do is to copy the base, then multiply all the exponents. In symbol, it is written as a raised to m raised to n. It is equal to a raised to m times n. Again, a is our base, m and n are the exponents of the expressions. From this idea, we can have our own examples. First, b raised to 5 raised to 2, it is equal to b raised to 10. Last example, we have 5 raised to 2 raised to 2, it is equal to 5 raised to 4. The value is 625. Next, the power of a product rule. The examples are quantity 2b raised to 3, that will be equal to 2 raised to 3, b raised to 3. The value of 2 raised to 3 is equal to 8, therefore the answer is 8b raised to 3. Next example, quantity xyz raised to 5, that will be equal to x raised to 5, y raised to 5, z raised to 5. Last example, we have quantity 2 times 3 raised to 3, it is equal to 2 raised to 3 times 3 raised to 3. The value of 2 raised to 3 is 8. The value of 3 raised to 3 is 27. 8 times 27, that will be equal to 216. Based on our examples, our conclusion is to raise expressions that contains 2 or more constants or variables that needs to be multiplied to each other. All you have to do is to distribute the exponent to each expression. In symbol, it is written as quantity a times b raised to n. It is equal to a raised to n, b raised to n. This time, a and b are the different bases, and then n is the common exponents. From this idea, we can produce our own example as quantity 4 times a times b raised to 2. It is equal to 4 raised to 2, a raised to 2, b raised to 2. The value of 4 raised to 2, it is equal to 16. Therefore, the final answer is 16 times a raised to 2, b raised to 2. Next, we have the power of a quotient rule. The examples are quantity 2 over 3 raised to 2 is equal to 2 raised to 2 over 3 raised to 2. The value of 2 raised to 2 is equal to 4. The value of 3 raised to 2 is equal to 9. Therefore, the answer is 4 over 9. Second example, we have quantity x divided by y raised to 5. It is equal to x raised to 5 over y raised to 5. Last example, we have quantity 5 divided by x raised to 3. That is equal to 5 raised to 3 over x raised to 3. The value of 5 raised to 3 is equal to 125. Therefore, the answer is 125 over x raised to 3. From the examples given, we can conclude that to raise expressions that contains 2 or more constants and or variables that needs to be divided to each other, we need to distribute the exponent to each expression. Then, simplify if possible. In symbol, it is written as the quantity a divided by b raised to n is equal to a raised to n over b raised to n. Note that a and b represents the different bases and n is the common exponent. From this, we can construct our own example, that is quantity 4 divided by y raised to 3, it is equal to 4 raised to 3 over y raised to 3. The value of 4 raised to 3 is equal to 64. Finally, our answer is 64 over y raised to 3. Next, the negative exponent. The examples are 2 raised to negative 3. It is equal to 1 over 2 raised to 3. The value of 2 raised to 3 is equal to 8. Therefore, the final answer is 1 over 8. Next example, x raised to negative 4. It is equal to 1 over x raised to 4. Last example, we have 3 raised to negative 4 times y raised to negative 2. It is equal to 1 over 3 raised to 4 y raised to 2. 3 raised to 4, the value is 81. Therefore, the answer is 1 over 81 y raised to 2. From this example, we can conclude that any expressions raised to negative exponent, it is equal to its reciprocal. In symbol, a raised to negative n is equal to 1 over a raised to n. From here, we can have our own example, such as 7 raised to negative 2 times x raised to negative 5, it is equal to 1 over 7 raised to 2, x raised to 5. 7 raised to 2 is equal to 49. Therefore, the final answer is 1 over 49x raised to 5. Lastly, the zero exponent. Our examples are, first, 5 raised to 0 is equal to 1. Second example, we have y raised to 0 is equal to 1. Last example, we have quantity 216 million x, y, z raised to 0. It is also equal to 1. From these examples, we can have our conclusion as any expression raised to 0, it is always equal to 1. In symbol, a raised to 0 is equal to 1, where a is any mathematical expressions. From here, we can have our example as, first we have 7 raised to 0 is equal to 1. Lastly, we have quantity 1000 x raised to 7 y raised to 20 raised to 0. It is also equal to 1.
Thank you. Once again, this is Teacher Anna, and I hope you enjoyed learning.